Thanks. So I want to tell you today, why don't you have to be afraid of chips and microcontrollers in your life? But let me start out with how I got into this whole thing. I was 16, 17, I just learned PHP and I was super enthusiastic because I could type stuff in a text editor and it would change stuff on my screen. And then I was like, this is amazing, I can control this. And then a year later, I watched a talk by somebody who was like, I implemented my own TCP stack on a microcontroller. I was like, what's a microcontroller and what's a TCP stack? And I got into this, I got this microcontroller and I started programming and it was the whole magic of you can change the world just by writing text came again. It was this LED blinks. And that might sound like, oh yeah, LED blinks, I see that all day. But it's the first time you write this and you flash it and suddenly this thing does stuff I told it is a magic moment. And so far from everybody who did embed it, I heard back for them it was also the magic moment of this thing does something just because I did something, and the real world changes, not just a screen or audio or whatever. And I see many people nodding here. It makes me very happy. This also led me down a bit of a rabbit hole, so you might get addicted. I started with microcontrollers, then I got into systems programming, so be aware of it, do it in good doses. Who am I? I'm Tamme. I work at Tweedegolf. You might also have it pronounced as Tweedgolf or Tweedegolf. Our name is not really useful for international communication. But there I write system software, firmware software, but I also teach people how to program Rust, how to program Rust on microcontrollers. Or I go into companies and consult them how to get started and help them not to be afraid of chips. So, what is a chip? I was really happy to see that Tim in the morning in this keynote already showed a nice example of a microcontroller. Actually, microcontrollers are everywhere around you. So if somebody's like, oh, there's aliens and they're everywhere around you and they control everything. No, microcontrollers are everywhere around you and they control everything. It's in my coffee machine, which is for me critical infrastructure, my oven. It's at our football table at the office to count the goals, obviously. But also my mouse, which died right before I came here. It's everywhere. You might know them if you Google for them, you might find these little black squares, and it's yeah, this is a microcontroller. But you've got to realize everything that has an LED that does a bit more than just blinking probably has a microcontroller in it. You can get them from 10 cents for really, really small microcontrollers, low memory, low CPU performance, nothing. But it's a computer for 10 cents. You can plug into a device, and then your device doesn't just blink, but it can do corporate identity blinking, where you morse secret messages to whoever is looking. So these are everywhere around you. They control everything. So you better learn how to control them in order for them not to control you. Why would you want a microcontroller then? So it's either you want something that measures something in the real world, like temperatures, distances, acoustic levels, humidity, CO2, whatever, and you want to do something with it. Be it, I just want to report it to a time series database so I can log how the temperature in my office develops, or be it, I want something that starts beeping as soon as the CO2 level in my office starts rising too high and I should really take a break or something. Or the other direction is you have something which either needs to be cheap or small or needs to use little energy. So cheap, as I said, can be low down to 10 cents per computer. Small, these things fit in hearing aids, and sometimes you see people now who have hearing aids that are so small you can't see them, which, okay, that doesn't give you a sense of size because you can see it, but they can get really tiny. And energy-wise, you can have devices that run years on a single battery life. So you won't get everything. It's not like with Rust where you can choose 3 out of 3 with microcontrollers. Okay, you choose size or power level or price. But it's pretty cool, super versatile. A lot of them around, which can be kind of overwhelming, but let me guide you through a bit. So, what's inside these little things? You got a little CPU usually, which can be an ARM processor, not just quite as in your MacBook, but pretty close. It also executes ARM code. It executes a specific subset of that, but for the most part, it's a CPU. It can run instructions. It can run Rust code. You got some flash memory, which is non-volatile, so if you turn off the power, you turn it back on, the stuff is still there. Usually your program will live in flash memory. Then you got some RAM. That's just your ordinary standard RAM, which you have on your PC, where it's like you can write stuff, you can read stuff. Hopefully it didn't change in between. But you also have stuff which you don't find on your PC anymore. You have GPIO pins, which is basically all those little silvery things up there. Those are GPIO pins, so you can control, should there be current flowing out of this pin, or should there current be flowing into this pin, or should this pin just see what the voltage level is? You're fine. Like you can do almost everything you want. You can connect LEDs, buttons, whatever. And then you have more peripherals they're called. For example, a serial port you might know, or a USB interface, so you can connect it to your PC, or Ethernet on some microcontrollers, or Bluetooth, or Wi-Fi. Basically, anything that involves pushing or pulling electrons around, you might find in a microcontroller. Again, not every microcontroller has every feature under the sun, but if you need something specific, you can usually find it. Yeah. So, what does Rust look like on a microcontroller? Well, I would say it looks an awful lot like Rust on a PC. You still have structs, like here in output. You still have methods like new. You still have enums, like a level, which can be either low or high. You have loops. You have for loops, so you have also like all the iterator magic that you're used to. You still can't panic. You still have results. You even have async if you want to, and it's sometimes really, really handy on microcontrollers. I'm not going to cover async today, but if you start with it, you will can slowly work towards it, and it feels almost the same as on desktop, except we don't have the cent bound problem because we only have one CPU anyway. Who's going to be work stealing here? Yeah. But you might be like, I'm used to Hello World. This isn't Hello World. You're not even morsing out Hello World or anything. But you can have nice tooling in Rust, like always. You need something called a debugging probe, which is like this little box thingy or something like it. It just connects your PC directly to the CPU on the microcontroller and can tell it, hey, actually, CPU, please write these bytes into your flash, and then also please start executing from that address over there. And so you can, yeah, it's called a debug probe because you can also use it for debugging. So you can attach GDB and tell it, I want a breakpoint or something. And it can also give you a standard out back to your PC. So you can do hello world over and over again, and then you do cargo run, and through the magic of probe RS, which is a nice little tool that integrates with cargo, it just builds your binary, it flashes to the microcontroller, and gives you back the output that are printed. So yeah, so far nothing really to be afraid of. But you might be like, yeah, well, that's all like really, really simple. Like, tell me something, some real world use case for the whole stuff. Like what does it look like? Does it get way more complicated? And to that I tell you, it's pretty much like in server land or big computer land where you have your HTTP client, for example. You start out with like, I want to build my HTTP client. Okay, I want to get some data from the internet. So you start out with like, opening a TCP stream, and then you're like, oh, well, I should implement HTTP 3 for this. So you start reading the RFC and implement your own HTTP client, and then you find out, oh, no, I need to implement Quick for this. Well, okay, then you read the RFC for that and implement that. And then you figure out, oh, TLS. Yeah, okay, well, I'm going to implement TLS for myself. Well, not really. We're in RustLand. We don't need to reinvent the wheel here. We just use cargo. We do cargo add request in Tokyo, and then remember to pass -f full for all the features. And then we go to docs.rs, and then we just yoink the first example that we can find and put it in our code. And usually that's a good starting point. It will work most of the time. And it's the same basically for a microcontroller. So for example, I have this little CO2 sensor here. You're also going to see a picture later. And that thing is called SCD40. And so I went to crates.io and was like, SCD40. And it's like, here's a driver for that. It's called SCD4X because there's also an SCD41. And in microcontroller land, they really like to replace the I don't care about this number bit with an X. So that's like a driver for both of those chips. And then I went to the repository of that chip, yoinked the first example I could find. And it looks like this. Just create the sensor. You need to pass it an interface and a timer. OK, I'll get to that later. Then you need to tell it to start. And then you need to wait 5 seconds. And then you can read the temperature and the CO2 level and everything. And you'll notice here, like, I don't have to care about what the bits on the wires actually look like, just with HTTP, where I don't have to care about how does a quick packet look like on the wire when I start my HTTP request. This is like nicely abstracted away. I just get a struct back, and the struct has fields for CO2, temperature, and humidity, and I can just print it out like I did before with Hello World. Yeah. So you don't need to be afraid of this. Like, just do it the same that you would do on your HTTP server. Just find a crate that does it, go to the example section, start out with the example, and from there you build your application. Demo time. Let's hope the demo goals are well aligned today. I realized this is going to be really, really small to see for everybody. But this is my hardware setup. On the left, you see the little debugging probe from Raspberry Pi. In the middle is a development board with a little microcontroller on it. The microcontroller is from Raspberry Pi, and it's called RP2040. But other than the normal Raspberry Pis, it doesn't run Linux. It's just a microcontroller. The only thing it runs is the stuff that you put on it. And on the right, you see the little CO2 sensor called STD40. And between those, it's a connection called Stemmer QT by the folks from Adafruit. So you don't even need to solder any wires if you want to like wire up an example like this. And you can daisy chain it. Like you could plug in a display and another sensor and another sensor. You basically can build whatever you want without having to really rely on plugging in cables somewhere or figuring out how to solder something somewhere. Yeah, it's basically all abstracted away for you. Like also, is this hardware abstraction then? Maybe. So now comes the scary part. Open text editor. How does this look like? So we saw this part before, basically. Well, thanks Rust Analyzer for all the types. We have this little new, and then we start the measurement, and then we do a re-init, which is something I found in the docs for the chip, or for the crate of the chip. And then we do the whole, you want to print out the values, but I also added in a little, I want to change the color of this LED, which is currently very yellow, based on the CO2 level that's around. So basically, what I did here is I first went to the example section of the crate that supports this, this big board. I can show you on GitHub. There's a crate for that as well called Adafruit Metro RP2040, and it's an example for like how to control this color LED. And I just copied the whole thing basically into my thing, and then added the CO2 sensor stuff into that, and then just combined the two things. And now, like I measure something in the real world, and I react in the real world. Everything is fine. And this is also something like I heard in the morning. You shouldn't skip all the details in your, if you explain something. But I feel like here, you don't really have to look too deep into the details. You still can, like I still can do the whole go to definition, for example, for the clock setup, and find like how did they do that step by step. But you don't have to understand this in order to get started with microcontroller programming. You can just start out with, well, I want to build something, I find the right examples for it, I plug together some hardware, and then I can build stuff without having to understand every little detail. If you really want to learn the deep details, please go for it. The RP2040 is particularly nice from the datasheet because the folks at Raspberry Pi build it for education, whereas a lot of other vendors are more interested in selling a lot of chips, and then the datasheets are not as nice anymore. But this chip, you can read the data sheet, and it's pretty readable, but I might be biased then. I've done so many microcontroller stuff. Yeah, let's continue with this. So, I hope from this you can take away that if you can program Rust, you can also program microcontrollers, and you do not need to be afraid of them and not need to be scared. So, what should you do now? Try it out. Like, get one of these boards and plug something together. Think about what you might want to build. Like, what do you want to measure? What would you like to control? Like, did you always want to have a reminder for your coffee machine is still on or something? You can build cool stuff with this. And then also go out and ask questions to the people in the Rust embedded community, because most people in the Rust embedded community currently come from embedded and learned Rust. And so you might be part of the first generation that learned Rust and then came into embedded. So there might be a lot of questions where embedded people think, yeah, that's pretty obvious. Okay, I see that every day. That's fine for me. But you might not be. And then feel free to ask those questions. And most likely, if you have a question, there's also other people having the same question. And it's worth asking them, even if just for them to see. And then also, if you can, go out and try and tell others about the stuff you built. The Arduino and MicroPython communities are very great in like having articles for every chip under the sun and every idea you could have ever built. And there's blog articles for everything. We don't have that in the Rust world yet because, well, most people come from the embedded context and do it professionally or something, and then you can't talk about it because NDAs are a big thing in the embedded area. So if you build something and you think, I think this is cool, most likely other people will also think it's cool. And so write blog articles or post it on Mastodon or whatever. And if you're afraid that, well, I don't know if my blog article is correct, I don't know, I'm not an expert in this topic, can I really do that? Please just ping me on Mastodon or send me an email, and I'm happy to review them and give you feedback on them. Yeah, how should you continue from here? Like, maybe you're enthusiastic to actually start with it. There is something called the Discovery book, which is currently being rewritten. But you can already use it, already start to use it. It uses a little board called the BBC Microbit. I got some of those with me today, so if you want to try it out here without having to buy a board and so on, just meet me and I can borrow you one mutably. If you're more the video kind of person, go over to YouTube channel Rusty Bits. They have a selection of great videos on like getting started with microcontroller programming in Rust. And one particularly great video I can recommend is the video on async programming, because like they really start out from the bare, like, why do I want to do stuff concurrently? Like, how do I do that if I build it from scratch without any threads, without nothing? And ends up at like, actually, let's use async and await. And the whole story in between really tells you how async Rust works, not only on microcontrollers, but also in like high-end HTTP servers, because we use the same infrastructure as them. The whole ecosystem basically is, not the whole ecosystem, but the async function trades, they all the same on both platforms. And I think they're even more intuitive on microcontrollers, where you don't have an operating system you need to talk to, and you don't have ePOL or IOU ring or anything. You just have this microcontroller and it executes only your code. There's nothing else. You can see every instruction that is run on the thing and learn from there. So if you watch this on YouTube now, then go over to Rusty Bits async Rust video and start watching there. It was a great, great video. If you get stuck with the whole thing, like you build something and you just cannot figure out why this doesn't work on a chip, there's also a great Matrix channel called Rust Embedded, but I also have a link at the end of my presentation with a lot of lovely people who are, it's just a really lovely community around. Like all of Rust community, even in the embedded space, there's no people that are like, no, that's a stupid question, just go away. You first need to figure out how to run your own nuclear reactor before you can start this. It's like, actually people who just tell you, well, just look over there or look away. If you want to try and figure out like which drivers are available, like which of these boards can I actually buy and use directly, a side project of mine is actually doing some web programming for a change. I built a site called DriveRS, which lists out all the currently known Rust drivers for all the kinds of chips, and you can search for, I want a temperature sensor that has a dev board which I can just plug in with a cable. Or at least that's the vision. Like if you try it out and you're like, this website is weird, why does the embedded like weird web stuff? Please leave me an issue. I would like to learn more web. Yeah, that's it from my side. Contact me via email or on Mastodon, or everything is also in this GitHub repository, like all the slides and all the links for all the topics. Yeah, that's it.